From the colossal pyramids of Giza, standing as eternal testaments to the power and ambition of past civilizations, to the dizzying skyscrapers of glass and steel that scrape the sky in our most futuristic metropolises, humanity, with justifiable self-admiration, has always prided itself on its unparalleled architectural ingenuity. We've proclaimed ourselves, with almost absolute conviction, the supreme builders of this planet, the sole possessors of the strategic vision, technical skill, and superior intelligence needed to conceive, design, and ultimately shape the world to our will, transforming the landscape with every edifice. But what if this deeply ingrained perception, so fundamental to our identity as a species, were in reality an incomplete view, only half the truth? What if I told you that just beneath the seemingly familiar surface of our environment is in the most hidden, diverse, and often unnoticed corners of vast nature, exist true architects and masters of engineering, whose works not only rival in complexity and functionality, but, on certain occasions, with astonishing efficiency, even surpass our own grandest and most celebrated creations? Today, we'll embark on an unprecedented exploratory journey. It's meticulously designed to challenge and ultimately completely redefine our understanding of the concept of engineer. We'll dive headfirst into the astonishing and enigmatic animal world to unveil the most incredible, innovative, and complex structures ever conceived, designed and meticulously built by the creatures themselves. Prepare yourselves, because you are about to witness firsthand true masterpieces of natural engineering. Edifices ranging from virtually impregnable fortresses designed with millimeter precision for survival in the most hostile environments to delicate and ephemeral works of art erected purely for a purpose as universal as love and the perpetuation of the species. These constructions not only openly defy human logic and expectations, but reveal a level of collective intelligence, instinctive precision, and communal collaboration within the animal kingdom that will forever change how we perceive the capabilities of other life forms. Yes, these are the true masters of construction, the overlooked, underestimated, and often invisible engineers of Earth. And their stories, woven with threads of adaptation and survival over eons, are about to be told in all the detail they deserve. 1. Termites, builders of bioclimatized living skyscrapers. Can you even conceive of a subterranean and terrestrial metropolis rising majestically up to 9 meters high, encompassing within it an intricate, labyrinthine network of capillary tunnels, vast interconnected chambers, and a ventilation system operating with astonishing perfection, regulating the environment with clockwork precision? Such an architectural marvel is the tireless collective work of termites, tiny creatures that, acting in a symphony of impeccable coordination and rigorous division of labor, stand as the builders of structures larger and more complex in proportion to their minuscule size than any other on the planet. Their giant mounds, far from being mere haphazard earthen heaps, are, in essence, true living skyscrapers, meticulously built from an ingenious and extraordinarily resistant mixture of earth, saliva, and feces. This organic paste, once exposed to the air and consolidated, acquires a hardness and durability comparable to cement, resisting harsh weather and the passage of predators. However, the most astonishing and enigmatic feat of their architecture lies in their innate climate engineering, an ability that seems to anticipate the future needs of the colony. Within the colossal dense mass of these earthen giants, termites manage to maintain an almost perfectly constant and optimal internal temperature and humidity, a formidable achievement considering the exterior can experience drastic fluctuations from scorching heat exceeding 40 degrees Celsius to extreme sub-zero cold. This bioclimatic marvel is achieved through an ingenious system of passive ventilation, a complex network of deep tunnels descending to the cooler, more humid subsoil combined with strategically elevated towers and chimneys that capture even the slightest surface breezes. This aerodynamic design generates natural air currents and thermal convection that not only precisely regulate the colony's internal temperature, but also efficiently remove carbon dioxide produced by the respiration of the gigantic community and its fungal gardens. It is, in essence, an organic, self-sustaining, and astonishingly efficient air conditioning, filtration, and air purification system. functioning without a single piece of technology. Undoubtedly, it's a masterful lesson in bioconstruction and sustainability that our own engineering, with all its technological advancements and complexities, still strives to fully comprehend and replicate, inspiring new branches of research in biomimicry. 2. Beavers. Hydraulic engineers reshaping entire river systems. If the ingrained notion that the ability to drastically alter a natural landscape and its river systems is an exclusive prerogative of Homo sapiens firmly resides in your mind, it's perhaps because you haven't yet had the privilege of encountering the beaver. These semi-aquatic rodents are no mere river inhabitants. They're authentic and formidable ecosystem engineers, endowed with an innate ability and tireless determination to completely transform the dynamics of a river, stream, or wetland, and their extensive surroundings in a matter of mere weeks, or at most a few months. Their crowning achievement, the dam, is a monumental and ingeniously designed structure. Built with an expert and strategic mix of carefully felled logs, precisely interwoven sturdy branches, heavy rocks, and cohesive mud. This barrier can extend for hundreds of meters, drastically altering the natural flow of water, creating waterfalls, backwaters, and new channels. The fundamental purpose of this impressive dam is not merely aesthetic, but vital. It is the deliberate creation of a deep, tranquil pond, significantly raising the water level upstream and slowing its current until it becomes a serene, protected pool. The primary reason behind this formidable environmental alteration, safety, and resource access. Within the protection offered by this artificially created pond, beavers construct their home, the lodge, an isolated and carefully camouflaged fortress built from similar materials and with entrances strategically located below the water's surface, rendering it virtually inaccessible to the vast majority of terrestrial predators. The dam also guarantees them constant and safe access to their primary food source, as well as submerged and protected escape routes in case of threat. The astonishing ability of beavers to fell trees with the surgical precision of their teeth, transport heavy materials, and fit them together with almost millimeter accuracy, coupled with their tireless and amazing capacity to detect and repair any minor leak in the dam, makes them true fluvial architects and hydrologists. These rodents not only reshape the landscape to ensure their own survival and reproduction, but, doing so, create and sustain vital new aquatic and terrestrial habitats for countless other species, demonstrating a profound ecological interconnectedness and an environmental impact on a scale few other species can match. 3. Bowerbirds. Architects of art galleries and masters of aesthetic seduction, now let us prepare our senses for an architectural marvel whose purpose transcends the mere practical need for shelter or the search for food, elevating itself to a far more sublime, universal, and, in a way, inherently human purpose: love and the perpetuation of the species. Bowerbirds, native to the lush, biodiverse rainforests of Australia and New Guinea, reveal themselves as the supreme artists, interior designers, and decorators of the animal kingdom. Unlike most other birds that focus their constructive efforts on building functional nests for incubation and raising their young, male bowerbirds dedicate their formidable ingenuity and considerable time to the construction of complex and elaborate structures known as bowers. These constructions are built with a single, exclusive purpose: to impress, court, and ultimately attract females, thereby demonstrating their fitness as a mate. These bowers are in no sense nests for living in. They are, in fact, true open-air art galleries, or intricate labyrinths of carefully intertwined twigs that can take various architectural forms, from imposing towers and symmetrical avenues to elegant circular platforms. The most astonishing aspect of their creative process, and what truly sets them apart, is how they decorate them. With obsessive meticulousness, the males diligently collect hundreds or even thousands of objects of specific colors, often prioritizing vibrant blue. These treasures can be glistening berries, delicate fresh flowers, iridescent insect wings, polished shells, and even human discarded items like plastic bottle caps, small fragments of colored glass, or tiny pieces of jewelry. The complexity of the architectural structure, the quality and quantity of the artfully arranged decorative objects, and the immaculate cleanliness of the bower are the rigorous criteria the female uses to evaluate and ultimately choose the male she deems most suitable. It is a fascinating demonstration of aesthetic, psychological, and cognitive ingenuity, where architecture is not just a biological necessity, but transforms into an elaborate courtship dance. A true open-air museum designed with a single powerful intention, to ensure the continuity of their lineage through art and visual persuasion. 4. Weaving spiders. Masters of silk nanotechnology and perfect traps from the majestic spiral of a spider web that catches the morning sunlight. Adorned with thousands of dew pearls shimmering like diamonds, to the intricate networks hidden in the shadiest corners of a forest or a barn, weaving spiders stand as nature's most astonishing, efficient, and technologically advanced materials engineers. Their primary construction material, spider silk, is no ordinary fiber. It's a protein biomolecule with physical properties so extraordinary that cutting-edge scientists tirelessly study it in nanotechnology labs to replicate its properties for industrial and medical applications. Pound for pound, spider silk is stronger than the highest quality steel. And at the same time possesses an elasticity and flexibility that far surpasses even the toughest nylon. Each individual spider is a living laboratory, capable of producing up to 7 distinct types of silk, each secreted by specialized glands, and designed with a specific purpose, optimized for its function within the complex web. There's silk for the structural framework of the web, silk for the sticky spiral that traps prey, silk for secure anchoring to surfaces, silk for wrapping and neutralizing captured prey, and even specialized silk for building its own temporary shelter, or the egg sac that will protect its offspring. The design of a spiderweb is an authentic marvel of structural engineering. In biomechanics, it masterfully leverages the principles of tension, elasticity, aerodynamics, and perfect geometry to create an exceptionally effective trap. This trap is capable of withstanding the impact of flying prey considerably larger and heavier than the spider itself, absorbing the kinetic energy of the impact without breaking. From the classic orb webs, with their circular radial geometry, considered the epitome of efficiency for catching flying insects, to the intricate funnel webs leading to subterranean shelters, or the complex 3D webs that, though seemingly chaotic to the naked eye, are in fact lethal and extremely efficient traps. Each web design is a masterpiece of physics and biology. They are perfect adhesive traps, camouflaged shelters, or signaling structures, built with an instinctive precision and a tacit understanding of nature's forces that defy our full conscious comprehension. The unfathomable wisdom and silent mastery of natural builders. From the imposing, naturally ventilated skyscrapers standing as monumental testaments to the ingenious social architecture and thermoregulation of termites, to the massive dams that reconfigure entire river ecosystems, a peerless feat by beavers transforming the landscape to their will. From the astonishing, ephemeral art galleries meticulously built and decorated by Bowerbirds, dedicated purely to love and demanding mate selection, to the ingenious and extraordinarily resilient silk networks of spiders, true marvels of materials nanotechnology that defy human physics. We have witnessed the astonishing, diverse, and unwavering capacity of the architects of the animal kingdom. These structures, far from being mere acts of blind instinct, are not the result of conscious human planning, complex mathematical calculations derived from equations, or the manipulation of sophisticated mechanical tools. They are, on the contrary, the fruit of millions of years of relentless evolution, of an innate wisdom deeply rooted in their genetic code, of a tacit understanding of the laws of physics, and of a perfectly synchronized collaboration on a scale often unimaginable to our minds. These living wonders of biological engineering powerfully and humbly remind us that architecture and engineering, in their purest and most functional essence, are not disciplines exclusive to Homo sapiens. Nature, through the diversity of its creatures, has developed solutions for design, construction methods, material utilization, and efficiency principles that, with astonishing frequency, surpass and inspire our own most advanced technological achievements.